Whenever you walk into a huge modern building, a skyscraper, an airport, have you ever stopped to think about what's really running the show? It's not just the people. It's something hidden, this invisible intelligence, a digital brain that's managing everything behind the scenes. Well, today, we're going to pull back the curtain and meet that brain, the building management system.
Think about it. You've got a massive building, maybe thousands of rooms, tens of thousands of people, and you have to keep them all comfortable, safe, and do it all without wasting a crazy amount of energy. That is a huge challenge. But the solution is actually pretty amazing.
So, let's imagine for a second what a big building would be like without a brain. It would be total chaos, right? You'd have the heating system fighting a war with the cooling system, lights would be blazing away in totally empty rooms. It would be this giant, inefficient, energy-sucking monster.
Okay, so how do we fix all that chaos? Well, it's simple. We give the building a brain. That's the building management system, or BMS for short. It's the central command center that gets everything to work together.
So, what is a BMS, really? You can think of it as the ultimate control system for a building. It's this computer-based network that hooks into all the important stuff. We're talking HVAC, lighting, elevators, you name it, and it gets them all to work together in perfect harmony. You might also hear it called a BAS, or Building Automation System. They mean the same thing.
Now, this digital brain is always on, always working. And its job really boils down to 4 essential functions that keep the whole operation running smoothly.
First up, it's always monitoring. It's like a tireless watchdog, keeping an eye on everything from the temperature in a room to the CO2 levels. Second, it uses all that data to control things. Too warm, it tells the AC to kick in. And third, and this is a big one, it's constantly finding ways to optimize. It's a genius at saving energy by, say, dimming the lights when the sun is shining in. And finally, it does a ton of reporting, keeping meticulous records of everything, which is super important for buildings trying to get those green certifications like LEED.
Okay, so how is this brain actually built? Well, you can think of it like a building's nervous system. It has different layers that handle different jobs, and they're all constantly talking to each other. Let's break it down.
At the very top, you have the management level. This is the big picture view, the user interface where a building manager can see what's going on. Down in the middle, you have the control level. This is where the heavy lifting happens, with powerful processors making all the moment-to-moment decisions. And then you have the field level. This is where the system actually touches the real world, with all the senses and muscles out there on the ground.
And that field level is where things get really interesting because you have this great partnership between 2 types of devices, sensors and actuators. Sensors are the building's eyes and ears. They're the thermometers, the CO2 meters, the things that collect all the data. And then you have the actuators. They're the muscles. They take the orders from the brain and actually do something, like turn a valve or dim a light. But the real magic, the true power of a BMS, comes from its ability to tie all of a building's separate systems together, to make them work not as individual parts, but as one single intelligent machine.
And this is where it all comes together. The BMS is the master conductor of this huge orchestra. It's handling the HVAC system, which is usually the single biggest energy user. It's managing the lights, using clever tricks like daylight harvesting to use sunlight instead of electricity. And it's also connected to the really critical stuff, like the life safety systems, the fire alarms, the elevators, to keep everyone safe.
But here's a thought. You've got equipment for the lights from one company, the AC from another, and the elevators from a third. How on earth do they all talk to each other? Well, they need a shared language.
And these shared languages are called communication protocols. Now, the undisputed king is a protocol called BACnet. It's the international standard, the one that almost everything uses. But you'll also see other specialized ones, like LawnWorks, which is great for things like lighting, and Modbus, which you often find on heavy-duty industrial gear and power meters.
All right, that was a lot to take in. So how about a little pop quiz to see what's stuck? Don't worry, it's just for fun. Ready?
First one up. What is the main #1 goal of putting a BMS in a building? Is it A, B, or C?
And the answer is B. It's all about that double whammy, making the building as energy efficient as possible while also making sure everyone inside is comfortable. It's a win-win.
Okay, next question. We talked about this clever term earlier. What exactly is daylight harvesting?
You got it. It's C. It's such a smart, simple idea, right? If you've got perfectly good, free light coming in from the sun, why pay for electricity? That's what daylight harvesting is all about. Question number 3. Which one of these is a common language or communication protocol used in building automation? Yes, it is BACnet. Remember, that's the universal translator that lets all the different pieces of equipment from all those different brands speak the same language.
And for our last question, back at that field level, which device is the muscle, the one that actually performs a physical action?
The correct answer is B, the actuator. Here's an easy way to remember it. Actuators act. They're the ones that get the job done, the hands and feet of the whole system.
So, there you have it. Our buildings are no longer just passive boxes of concrete and steel. They have a digital brain. They can sense, they can think, and they can act to save incredible amounts of energy and make our lives way better. And that just leaves us with one final exciting question. Now that our buildings can think, what amazing new things will they think of next?